Welcome back. If you watched our last video, you saw how my daughter built a 100 chart and discovered some fascinating patterns in the number system. But guess what? This chart has even more patterns waiting to be discovered. Let's dive deeper. Look closely at the numbers on the 100 chart. Some are tall like skyscrapers, some are shorter like houses, and some are just single blocks. Think of them as number buildings, each built from prime number cards. These cards are the foundation of all numbers. Now, take a moment to observe these number buildings. Does a bigger number always mean a taller building? It might seem that way at first, but let's put that idea to the test. Look at 42 and 43. The number 42 is built using 3 cards, 2, 3, and 7, but 43 stands alone with just 1 card. So, a bigger number doesn't always mean a taller building. Can you tell me why? Exactly. The number 42 is not prime, while 43 is a prime number. The way these buildings appear on the chart seems almost random, like a mathematical puzzle. Isn't that interesting? Let's focus on the prime numbers, the 1-card buildings. Scan the chart. Do you see a pattern? Can you predict where the next prime number will appear? Try it. Do you see any clues? Prime numbers are spread all over the place. Is there a perfect rule for finding them? You might think you've found a pattern, but sometimes it doesn't work out. For hundreds of years, mathematicians have tried to find an easy way to predict prime numbers, but they have not figured it out yet. It's a big mystery. But that doesn't mean there are not any patterns. Let's take a closer look at consecutive numbers. Notice something? They share no common prime cards. Mathematically, they have no common factors other than 1. Do you know what we call such numbers? That's right, they are called co-prime numbers. That's why any 2 consecutive numbers are always co-prime. But what about numbers that are not consecutive? Can you find 2 numbers on the chart that are co-prime but not right next to each other? Look carefully. Remember, co-prime numbers have no common prime cards. You got it. 8 and 15 are co-prime, and 25 and 36 are too. Do you see any patterns in these pairs? Pause the video and try to find more co-prime numbers. Share your findings and any patterns you notice in the comments below. We have uncovered some fascinating patterns so far. By the way, did you like this video? Why not share it with a friend, classmate, or even your maths teacher? They will enjoy exploring these patterns too. Now, let's explore another interesting pattern. Take a step back and look at the chart again. Let's start with something simple, even and odd numbers. What do all even numbers have in common? That's right. Every even number has at least 1 card of 2. No matter how big or small the number is, if it's even, it must include a card of 2. Can you think of why? And what about odd numbers? Exactly. They never have a card of 2 because they are not divisible by 2. That's what makes them stand apart from even numbers. Next, look at multiples of 3. What do you notice? Absolutely. Every multiple of 3 has at least 1 card of 3. And multiples of 5? Yes. They all have a card of 5. Each prime number seems to have a signature card that appears in all its multiples. While building the 100 chart, my daughter noticed that if a number is divisible by both 2 and 3, it is also divisible by 6. Let's take a closer look and understand why. Think of it this way, every number with a card of 2 and card of 3 automatically has a card of 6 hidden inside. Since multiplication is just attaching these cards together, having both 2 and 3 means you can always form 6. That's why numbers like 12, 18, and 24, each with at least 1 card of 2 and 1 card of 3, are also divisible by 6. But here's a question, if a number is divisible by 4 and 6, does it have to be divisible by 24? Take a look at the chart and see what you find. Great thinking! Actually, no, it doesn't have to be divisible by 24. A number like 12, which is divisible by 4 and 6, is not divisible by 24. That's an interesting finding, isn't it? Can you find other numbers that show a similar pattern? Share your examples in the comment box below. This simple way of building numbers is just the beginning. Countless patterns, hidden within multiples, factors, LCM, HCF, divisibility, and even the properties of exponents, are waiting to be uncovered. Instead of memorizing rules, you will understand why they work. That's the magic of exploring numbers visually. Think of this chart as a periodic table of numbers, unlocking secrets you might never have noticed before. Want to explore it yourself? Download the 100 chart from the link in the video description below. See you in the next video. Until then, keep building, keep exploring, and keep uncovering the amazing patterns hidden within our number system.